days are. Do we still need to grade 6-5?
Yeah.
Can't remember. Maybe let's grade 6-5 later, or you want to grade it now?
That's going to be a lot of catching up.
A lot of catching up, yeah. So we'll jump into the 6 category and go from there. 6-6 is trapezoids. Okay, trapezoids. There is essentially what it is it is a triangle with its head cut off, and is what it ends up being. So a trapezoid, though, by definition, it's a quadrilateral, but by definition it has only one set of parallel sides. So a trapezoid, by definition, has only one set of parallel sides. This is 7-6 trapezoids. So if you looked at like a triangle, like this, there's our triangle, and you took the top and you cut it and got rid of it, like this, you would end up with a trapezoid. So by definition, trapezoids can only have one set of parallel sides. So this side parallel to that would be a trapezoid. You know, a quadrilateral, I mean, it may kind of look like a trapezoid, maybe, but that is not a trapezoid, just visually, because no sides are parallel, so not a trapezoid. Right? So in that, though, this is just a general trapezoid. A trapezoid can have a median. A median on a trapezoid would go like this, and what it would do is it would cut this side in half and cut that side in half, so that would be the median of the trapezoid. Trapezoids typically have what we would call two bases, and we would say, you know, this would be base. It doesn't matter if we say base sub 1 or base sub 2 up there, but we would consider them to have two bases like that. A trapezoid also will have a height to it. The height, as you recall, is not defined from this point to this point. The height is always defined by where it makes a 90, and that would be the height of the trapezoid. We then have one special trapezoid we refer to, and that is an isosceles trapezoid. An isosceles trapezoid is what we think of kind of like an isosceles triangle, right? But the top is gone. In an isosceles trapezoid, since it's a trap, those two are parallel. They're not equal, but they're parallel. But the sides here are congruent in an isosceles trapezoid. Therefore, your base angles are equal like that. Also, if those two angles are equal, these upper two angles are equal as well. Okay, so that's an isosceles trapezoid. Now, there's a formula that we'll pay attention to, and that is where are we here? The median. That's what I wanted. Well, for starters, diagonals on an isosceles trapezoid. The diagonals in an isosceles trapezoid, what do you think we know about them? They are not perpendicular, but it's a guess. They are congruent, yeah. They don't actually bisect each other in a trapezoid, right? In a parallelogram they do, but not in a trapezoid. But they are congruent in an isosceles trapezoid. Those diagonals are congruent. Now, the thing I wanted to state about the median is the median of a trapezoid is parallel to the bases. I didn't state that up here. But the median, like we've drawn here, that would be parallel to the bases. And then a little formula for the median, not the medium, median, so is equal to, I believe it's 1/2 the sum of the bases added together. So base 1 plus base 2 divided by 2 is equal to the median. And they state a median of the trapezoid is parallel to the bases, and its measure is 1/2 the sum of the measure of the bases there. Okay, so that would be a trapezoid, and let's see if there is some problems that we could take a look at. Okay, so if you have a trapezoid like this, now remember the median does not have to be an isosceles trapezoid, so if we were doing a problem like this, and this is now they would have to either state that this is a trapezoid or give you information like this Okay, once you see that parallel to that, you know trapezoid. If you see this, then you know that's a median. They'd probably also just say like A, B, C, D, and you know C, D is the median of the trapezoid or something. But if this is the information, we know it's a trapezoid. Let's say I give you, let's go with 6x minus 3. We'll call this 15, and we'll call this 8x plus 5. We'll go with 8x plus 5, okay? And we want to solve for x. So all we would do there is take a look at the fact that we're dealing with the trapezoid, dealing with a median, and we come back over here to our little formula that we have, and we would say, the median is equal to 1/2 the sum of the bases, right? Added together, right? Sum of the bases divided by 2. So you take your information, the median is the one in the middle, we say, okay, that's 15 is equal to 1/2, and then base 1 minus 3 plus base 2, x plus 5, 8x plus 5. One thing you can do is if you want to distribute the 1/2 thing, you could. I usually don't. What I usually do with that 1/2 is get rid of it by multiplying both sides by 2. And so I would get the 30 over there, and then 14x plus 2. In this case, it would have worked fine to have the 1/2 distributed in because they're both even numbers, but either way is fine there. A lot of errors on the mid-chapter assessment I saw, people doing things like this. You know, what do? We added 2 to both sides. There's a lot of those. Or they would, I don't know what the other ones were. They added 12 to 28 and they got 30, and 12 plus 28 was 30. There's several little errors like that on the mid-chapter assessment. So we don't add the 2. What do? Subtract it, so you get 28. And so then in this case, x is just equal to 2. What other things? Do you want to do an XY plane one? Those are always like the challenging ones for people. Here we go. Find the length of the median. This is going to be an XY plane one. Find the length of the median of the trap. And then we're going to give the vertices 3. So it's going to have vertices 10, 1, and 7, 9. So the nice thing is you don't have to prove that it's a trapezoid. They already tell you it's a trapezoid. If you needed to prove that something was a trapezoid, you would want to prove that it would be a shape with only one set of parallel sides. So, you know, if you did that, you would state same slope, and then 2 different slopes, and now you've proved trapezoid. But this one, you could draw a little picture if you wanted. Over 3, up 1, over 10, up 1. Hey.
Hi, sorry, may I take Lily, please?
No, I mean, yes.
Thank you.
You may take Lily. 7, over 5, up 9, and over 7, up 9. Okay. So based off this little picture, this sure enough looks like a little bit of a trapezoid. And so what they want to find is the length of the median. Okay. So median, I'll do it in red here. I want to find this length, the part that goes from here to here. What is the length of that? So you're going to need to find the distance, right? Now, if you want to find the distance of a line, what do you need? You need the endpoints, right? So how do I, I know these 4 corner points. So sure, I can find the distance of those, but I'm looking for the distance of the median. So there's 2 routes you could go on this, actually. If you want to find the distance of the median, what do we know the median is equal to? We got a little formula, right? Half the what? Both bases added together divided by 2. So could we actually pretty easily find the distance from here to here and here to here without actually having to do much of a distance formula at all? Yeah, why don't I need to do the distance formula on that? To find this distance from here to here. Because what kind of line is it? Horizontal. So if it's a horizontal line or a vertical line, you can just count, right? So how many spaces are between this and this? Well, look, this one is like over, what, 7 up 9, over 5 up 9. So what's the distance between the two? 2. And then what's the distance from here to here? This is over 3, this one's over 10, so what's the distance? 7. So if I actually want to know the distance of that one's actually pretty easy. I just go 1/2 the sum of 2 plus 7, and you get out 4.5, right? Or you get out 9 over 2. Now that's if you're able to count because we have horizontal lines, right? What happens if you don't have horizontal lines and you couldn't just count? So like on a test, this would be fair to say, oh, it's a horizontal line, I'm just going to count. That's fine. But what if it wasn't horizontal lines? You would have to do the distance formula to get from there to there, right? Distance formula to get from here to here. Have those two distances, plug them in right there. So you do 2 different distance formulas. What's the other way that I could do this? Find the distance of the median.
Midpoint.
Yeah, if you find the midpoint of this and the midpoint of this, then you can find the distance between those two is another route you could go. And the midpoint formula, you remember the midpoint formula? Midpoint formula is equal to, it's a coordinate point because you're finding the point in the middle, right? It is your x's added together, right? So if we were going to find the midpoint of this one, it would be like 3 plus 5, this and this. That's 5, 9, this would be 3, 1. It'd be 3 plus 5 divided by 2, and then 1 plus 9 divided by 2. So the midpoint of that would be 4, 5. And that would be the midpoint right there. So you find that midpoint, that midpoint, and then do the distance formula. So there's a couple different routes you could go. 3, in fact, for this one, because you have horizontal, horizontal, and so that's just the counting method. So if you can count, because of the horizontal line, do that route. Otherwise, you'd have to do the distance formulas. Okay? So that's the basics of trapezoids. I don't think there's anything else. I think that's it. Okay? So utilize your time, get your homework done, and then work on your mid-chapter assessment corrections. You can work together on those, and then maybe prepare, when you go home today, potential that there's no school tomorrow, potential, so think about that when you grab your stuff and you're taking it home with you. Maybe, take whatever you want for the next couple of days, possibly. Just a pro tip. They might cancel, who knows, or they might not. Okay, best of luck, or take a nap holiday. Looks like you need a nap.